Modern humans thrived while Neanderthals disappeared, but not due to their brains, according to Nicholas Longrich on The Conversation. Why did humans take over the world while our closest relatives, the Neanderthals, became extinct, is the question. It's possible we were just smarter, but there's surprisingly little evidence that that's true. Neanderthals had big brains, language, and sophisticated tools. They made art and jewelry. They were smart, suggesting a curious possibility. Maybe the crucial differences were not at the individual level, but in our societies. 250,000 years ago, Europe and Western Asia were Neanderthal lands. Homo sapiens inhabited southern Africa. Estimates vary, but perhaps 100,000 years ago, modern humans migrated out of Africa. 40,000 years ago, Neanderthals disappeared from Asia and Europe, replaced by humans. Their slow, inevitable replacement suggests humans had some advantage, but not what it was. Anthropologists once saw Neanderthals as dull-witted brutes, but recently, archaeologists' finds show that they rivaled us, Homo sapiens, in intelligence. Neanderthals mastered fire before we did. They were deadly hunters, taking big game like mammoth and woolly rhinos, and small animals like rabbits and birds. They gathered plants, seeds, and shellfish. Hunting and foraging all those species demanded deep understanding of nature. Neanderthals also had a sense of beauty, making beads and cave paintings. They were spiritual people, burying their dead with flowers. Some circles found inside caves may be Neanderthal shrines. Like modern hunter-gatherers, Neanderthal lives were probably steeped with superstition and magic, their skies full of gods, the caves inhabited by ancestor spirits. Then there's the fact Homo sapiens and Neanderthals had children together. We were not that different, but we met Neanderthals many times over many millennia, always with the same result. They disappeared and we remained. The hunter-gatherer society, it may have been the key difference where less than the individual level than at the social level, societal level. It's important and it's impossible to understand humans in isolation any more than you can understand a honeybee without considering its colony. We prize our individuality, but our survival is tied to larger social groups. Like a bee's fate depends on the colony's survival. Modern hunter-gatherers provide our best guess at how early humans and Neanderthals lived. People like the Namibia's Khoisan and Tanzania's Hadzabe gather families into wandering bands of 10 to 60 people. The bands combine into a loosely organized tribe of 1,000 people or more. These tribes lack hierarchical structures, but they're linked by shared language and religion, marriages, kinships, and friendships. Neanderthal societies may have been similar, but with one crucial difference: smaller societal groups. The tight-knit tribes, what points to this is evidence that Neanderthals had lower genetic diversity. In small populations, genes are easily lost. If one person in 10 carries a gene for curly hair, then in a 10-person band, one death could remove the gene from the population. In a band of 50, 5 people could carry the gene, multiple backup copies. So over time, small groups tend to lose genetic variation, ending up with fewer genes. In 2022, DNA was recovered from bones and teeth of 11 Neanderthals found in a cave in the Altai Mountains of Siberia. Several individuals were related, including a father and a daughter. They were from a single band, and they showed low genetic diversity. Because we inherit 2 sets of chromosomes, one from our mother, one from our father, we carry 2 copies of each gene. Often we have 2 different versions of a gene. You might get a gene for blue eyes from your mother and one for brown eyes from your father. But the Altai Neanderthals often had 1 version of each gene, and as the study reports, that low diversity suggests they lived in small bands, probably averaging just 20 people. It's possible Neanderthal anatomy favored small groups. Being robust and muscular, Neanderthals were heavier than us, so each Neanderthal needed more food, meaning the land could support fewer Neanderthals than Homo sapiens. And Neanderthals may have mainly eaten meat. Meat eaters would get fewer calories from the land than people who ate meat and plants, again leading to smaller populations. Group size matters. If humans lived in bigger groups than Neanderthals, it could have given us advantages. Neanderthals, strong and skilled with spears, were likely good fighters. Lightly built humans probably countered by using bows to attack at range. But even if Neanderthals and humans were equally dangerous in battle, if humans also had a numeric advantage, they could bring more fighters and absorb more losses. Big societies have other subtler advantages. Larger bands have more brains to solve problems, remember lore about animals and plants, and techniques for crafting tools and sewing clothes. Just as big groups have higher genetic diversity, they'll have higher diversity of ideas. And more people means more connections. Network connections increase exponentially with network size. Following Metcalfe's law, a 20-person band has 190 possible connections between the members, while 60 people have 1,770 possible connections. Information flows through these connections, news about people and movements of animals, tool-making techniques and words, songs, and myths, plus the group's behavior becomes increasingly complex. Consider ants. Individually, ants are not smart, but interactions between millions of ants lets colonies make elaborate nests, forage for food, and kill animals many times an ant's size. Likewise, human groups do things no one person can, that is, design buildings and cars, write elaborate computer programs, fight wars, run companies and countries. Humans are not unique in having big brains. Whales and elephants have these, or in having huge social groups like zebras and wildebeest from huge herds. But we're unique in combining them. To paraphrase poet John Donne, no man and no Neanderthal is an island. We're all part of something larger. And throughout history, humans formed larger and larger social groups, bands, tribes, cities, nation-states, international alliances. It may be then that an ability to build large social structures gave Homo sapiens the edge against nature and other hominin species. This is from the conversation under here, Creative Commons, by Nicholas Longrich, Senior Lecturer in Paleontology and Evolutionary Biology, Life Sciences at University of Bath in the UK, on Live Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.